Hi chemists! We are starting our brand new unit on chemical quantities. In this unit we're going to focus a lot more on the quantitative aspect of chemistry, where now chemists are more concerned with the amounts of substances that we have. Today you're going to have a brief history lesson, and then we'll also learn about how we can use this new unit called the mole to count how many atoms, molecules, or this thing called formula units that we have in a sample. After today, you should be able to use dimensional analysis to calculate how many atoms, molecules, or formula units there are in 1 mole of a substance. Use correct sig figs and units in these calculations. Identify key scientists in the development of the mole. Substances, as you know, can be measured in many different ways. So you could count something. You could take the mass, or you can get the volume. As it turns out, the mole can be related to each of these types of measurements. So here's a brief history. First up, we have Avogadro, back in 1811. He is an Italian scientist who is given credit for discovering the mole, although at the time he didn't realize that what he discovered was this unit called the mole, but he is given credit. So he theorized that the volume of a gas at a specific temperature and pressure contains equal numbers of atoms or molecules regardless of the nature of the gas. What basically happened is he's realized that all these different gases contain the same amounts of particles as long as they were at specific temperature and pressure conditions. Next up with Loschmidt, where he estimated the diameter of molecules in the air, and he was able to calculate the number of particles in a given volume of gas. Millikan was next. He measured the charge on an electron, and from this charge, he was able to calculate the charge on a mole of electrons. He divided the two numbers and obtained Avogadro's number. And finally, we have Perrin. He earned the Nobel Prize for computing Avogadro's number using many different methods, and he named the constant in honor of Avogadro. As it turns out, we have changed the standard. We actually went from oxygen now to carbon. So in order to define the mole, we say that carbon-12 is what the mole is based off of. So the accepted definition at this point is the amount of any substance that contains as many elementary entities as there are in 12 grams of pure carbon. So elementary entities just means atoms of carbon. The mole in chemistry, which is abbreviated MOL, is a unit that really serves chemists to kind of have a bridge between the atomic, like the really teeny tiny, and the macroscopic, where you can actually measure these atoms and molecules on a balance. In Latin, believe it or not, the term mole means huge pile. So there you have it. That is a mole. 1 mole equals 6.02 times 10 to the 23rd atoms, molecules, or formula units. In chemistry, there's a certain grammar that we use. So for example, if we're talking about copper, we would talk about copper atoms. If we were talking about water, we'd be talking about water molecules. And if we had ionic compounds, then we'd be talking about formula units in terms of, let's say, sodium chloride. So that's the grammar that's associated with this. Students tend to get a little freaked out when you see formula units, but no reason to freak out. It means the same thing as atoms, molecules. So check this number out. It is huge. Look at all those zeros. Completely enormous here. So this number is 602 sextillion. Wow, that is quite a lot in the sample. So this equality we are going to use in chemistry to calculate, go from particles into moles or moles into particles. So here's an example, a very common example. To do this, you are going to have to use dimensional analysis, and that you have learned previously. So for example, it says, how many atoms are in 1.22 moles sample of sodium? You know me by now. I always like to include the known and the unknown. So I know that I have 1.22 moles of Na, and I want to know how many atoms of sodium I have. You may say, Miss Raz, do I need to put the symbol for sodium? My answer is really no, but I will say it would probably be in your best interest to do that because eventually you are going to have to. So let's get into good habits now, and let's start writing the symbol with everything. As I mentioned before, when we did dimensional analysis, the known stands for what we know, the U stands for what we are solving for. So we'll start with our known, and we will put it over a 1. We'll then take our multiplication sign and our line. So in this case, we see that we have 1 mole equals 6.02 times 10 to the 23rd atoms of sodium. So this conversion factor is always going to be the same regardless of the substance that we have in question. And then you can see very clearly that moles and moles divide out, and we're left with atoms of sodium. Your significant figures are based off of the known usually, just to make it a little bit more simplistic. So since there's 3 sig figs here, there will be 3 sig figs in your answer. If you end up getting a number that is like times 10 to the 40 something or 50 something, that means that you don't know how to use your calculator and you should see your teacher for some extra help. Let's try another one. So this one says, how many moles are equal to 4.79 times 10 to the 24th molecules of CO, or carbon monoxide? So just like we did, we'll do our known and we'll do our unknown. Be really careful if you want to abbreviate the word molecule, which I don't blame you because it is a longer word. However, do not under any circumstances write MOLE as the abbreviation because then you'll confuse it with mole. So we'll start with our known and we'll put it over 1. Notice that you have molecules up here. So that means when you do your next conversion factor, you have to have molecules on the bottom in order for it to divide out. And then when you do this, you should see molecules and molecules divide out, and you're left with mole, which is exactly what you want. This is the calculation that a lot of students tend to mess up on if they don't know how to use their calculator. Remember, as I said, if you get times 10 to the 50-something or 40-something, that means you probably did something wrong. So when you calculate it, you should get 7.96 moles of carbon monoxide. I always tell my students, in order to be successful with calculations with the mole, you have to practice. So hopefully you got a practice worksheet from your teacher so that she can or he can help you. Thank you so much for watching, chemists. I think you did a great job today.